I am trying to use the rational zero test to factor this third degree polynomial 3x to the third plus 17x squared plus 2x minus 40. And then the first step you have to do is you have to find the possible rational zero, which is you will be using the factors of constant negative 40 divided by the factors of leading coefficient, which is a 3. So factors of negative 40, that means what number times what number is equals to 40. The first thing that I am thinking about is 1 and 40, right? So you'll be taking plus or minus 1 and then plus or minus 40. Why do we include the plus or minus? Because you have a negative 40, it can be negative 1 times positive 40, it can be positive 1 times negative 40. That's why you have to take care of the plus or minus. And then 2 times 20. So I will do a 2 right here, and then a 20 right over there. And then what else? How about 4 times 10? So 4 times 10, and then what else? One more. 5 and 8. I think that's it. And then how about 3? 3 is positive 1 times positive 3, negative 1 times negative 3. So you will have to include the plus and the minus. Now, the next line you have to pay attention. The next, let me match the color code so I don't do red on top and bottom. So the next, this should be in yellow, right? So 1 times 3. So the next line, pay attention. So the next line, you will have to use every red number in the numerator divided by the plus 1 in the denominator first. So that means you will just have to copy the whole thing again. So that will be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5. This is a 1 divided by 1, 2 divided by 1. So 1 divided by 1, 2 divided by 1, 4 divided by 1, 5 divided by 1, 8 divided by 1, 10 divided by 1, so on and so forth. So 5, 8, 10, and then 20, and then 40. And then next, you have 1 divided by 3, 2 divided by 3, 4 divided by 3, 5 divided by 3, so on and so forth. As a result, you have a 1/3, and then you have a 2/3, and then you have a 4/3, and then you have a 5/3, and then you have a 8/3, and then you have a 10/3, 20/3, and 40/3. You have to include a plus or minus for all of them. Now, this list of possible rational zero is extremely long. On the test, if you have to test them one by one, that might take a long time. So in my class, in my in-class written exam, I usually give a few numbers for people to try, and I will hide the correct answer in the second number. So when they try the second number, they will get the zeros immediately. So they don't need to waste like 10 minutes to try the numbers one by one. All right. And then the next step, I will just write test f of plus or minus 1. You just have to test all of them, plus or minus 2, and then so on and so forth. So what is the first number that works? The first number that works is f of negative 5. So this is equals to 0. What that means is this x plus 5 is one of the factor. Do you know why? So this is a third degree, right? So we should get equals to 3 parentheses, right? And then x plus 5 is one of them. Because when you set the factor form equals to 0, x equals to negative 5, right? X equals to negative 5. So when you plug in negative 5 to the given function, you get a 0. All right, let's perform the synthetic division. The synthetic division, you have a negative 5. And then what else? You have to drop the leading coefficients down. So this is the third degree, the second degree, the first degree, and the constant. Pull the 3 down, 5 times 3, negative 15. Add them, you have 2 times negative 5. Add them, and then negative 8 times negative 540, and you subtract that, you have a 0. So this is a remainder equals to 0. So what that means is that just proves that x plus 5 is a factor. So what happens when x is not equals to 0? I can just give you a very fundamental example. So let's say you have a 15. You have a 15 equals to 3 times 5, right? Do we agree that 15 divided by 3 is equals to 5 with no remainder? If there is a remainder, then 3 is not a factor, right? It's not a factor. I should say it's not a factor in an integer. So 15 divided by 3 is equals to 5, no real number. So 3 is a factor. And then what is next? So the next step, I would like to use a different number to, I would like to use a different color to split that up. How about this? I will just use a purple. I will just use a purple. So what is this? This is the constant negative 8, and then first power plus 2x, and then a second power 3x squared. Now, I gave you a third degree, so now after you divide it by x plus 5, then you get a second degree. So for the second degree, what that means is you have f of x equals to x plus 5 times this 3x squared plus 2x minus 8, and then for the x plus 5, I should do that in green. You take what I gave you, you divide it by x plus 5, you get this. Just like you take the 15, you divide it by 3, you get a 5, but we put everything in our polynomials. And then the next step is you will have to try another one. So this time, negative 2 will work. So try f of negative 2. So that is equals to 0. So that tells me x equals to 2 is a factor. No, not x equals to 2. X plus 2 is a factor, and x minus equals to negative 2 is one of the zeros. So is a factor. And then I will just take 3, 2, and negative 8 as the dividend, and then divided by minus 2. So this is a plus 2, this must be a minus 2. They are always the opposite. If you don't remember this, just look up on my video called symphatic division. I fully explain that in symphatic division. Pull the 3 down. 3 times 2 is negative 6. Negative 6 plus 2 is negative 4. Negative 4 times negative 2 is 8. 8 plus negative 8 is equals to 0. So that tells me x equals to 2 is a factor. And then what is this? This one I should use a different color. So this is a constant, and then a first degree. So we have a 3x minus 4. Now, let's draw a summary. We performed 2 symphatic division. I would like to draw a summary of what we did. So first of all, I gave you a third degree polynomial right here. You don't have to rewind the video. 2x minus 40. And then we perform one symphatic division, right? First, we divide by x plus 5. And then we obtain 3x squared plus 2x minus 8. That is in purple right over here. That is what we got from the first symphatic division. And then you take this 3x squared plus 2x minus 8, and then you divide by x plus 2. This is equals to 3x minus 4. And then at the end of the day, you have your f of x equals to 3x to the third plus 17x squared plus 2x minus 40. That is, what is that equals to? That equals to the first factor you found, which is x plus 5. And then the second factor you found is x plus 2. And then the last factor you found, which is right over here, that is a 3x minus 4. 3x minus 4. Now, let me just copy this. So I'm going to copy this, copy, and then paste that over here. Now, I am going to set the whole thing equals to 0. We will look at the picture, we will look at the graph later. So what if I set this whole thing equals to 0? So you set that equals to 0, and then what do you get? You get x equals to negative 5, x equals to negative 2, and x equals to 4 over 3, right? So 4 over 3. So they are rational zeros. You obtain this using the rational zero test. But in case you ask, hey, negative 5 is not a rational number, I can put that in a rational number. Just simply write negative 5 over 1 or negative 2 over 1. So they are rational numbers. And then for the x-intercepts, we have negative 5, comma 0, negative 2, comma 0, and then 4 over 3, comma 0. So on the picture is right here, here, and then right over there. You have 3 rational zeros. All right, I would like to do a few more steps. So let's say we have a 30. So here is what we did. Let me just use a different example to talk about it. So let's say I gave you a 30. So do we agree that 30 is equals to 2 times 3 times 5? So what we did is the first thing, we take a 30 divided by 2. We have a 3 times 5. So 3 times 5 is equals to 15, right? And then we take a 15 divided by 3. We get a 5. And then at the end of the day, we divided by 2, and then we divided by 3, we obtain a 5. We said that the given polynomial is equals to the first factor you found times the second factor you found times the quotient you found. 2 times 3 times 5 equals to 30. This is exactly what we did, but we did everything using a polynomial, which is what the rational zero test is trying to do. You perform all these steps, you will be able to obtain all the rational zeros. And then the rational zeros, they are right over there. They are the x-intercept. If this is your first time watching my video, I construct this graph using Desmos, DESMOS. Is free. You can look it up on Google. You can download the app to your phone, all free. All right. So if you like the way I explain the rational zero test, give me a like. Give this video a like, subscribe, and I truly appreciate your help. And I will meet you all in the next lesson. Take care.